Welcome to MEI Modelling with Algorithms. We're on the topic of critical path analysis, and this is video 1.5, Resourcing and Scheduling. Now, this follows on from what we've already seen involving activity networks. We're now going to take the information that we've got at our fingertips from these activity networks in order to actually think about, in practice, what we might do on a factory floor, for example, in terms of scheduling, which is actually deciding exactly when particular activities are going to be scheduled to be carried out, and resourcing, which is actually allocating people or machinery or what have you to the individual tasks, and making sure, for example, if you have limited resources, that they are not overstretched, so that say you've only got 2 workers, that you're never having 3 activities happening at the same time, because that obviously wouldn't be possible. Now we're going to be using the example from the previous video to help us here. If you remember, in the previous video we found the critical activities and the critical paths, and I'll put those on there now, like so. And remember that those critical activities which are highlighted, they have 0 total float. So the first question to think about, and I would encourage you to pause the video here and see if you can work this out for yourself, is what is the total float for the other activities, the non-critical activities. So see if you can work that out now. So there you can see in green where I've worked out the total float for each of those activities. It's debatable whether it's necessary to do that for the dummy activities. You can obviously work out the total float, but in terms of what practical use that is, it's maybe less important than the other ones. It should be made clear in the question whether or not it's required to work out the float for the dummy activities. So with those floats worked out, that might help us to some extent to answer the following questions. So first question is, can D and F be carried out by the same person? So you can think about this yourself in a moment, but if we just find those activities to start with, activity D is here. You might want to look at the start and end times that are possible for that activity, and F is over here. Is it possible for them to be carried out by the same person? What about H and I? Can they be carried out by the same person? What effect would it have if we changed one of these durations? So for example, if we halved the duration of K, or if we doubled the duration of K, what effect would that have? So pause the video for a moment and see if you can answer those questions for yourself firstly. Thinking about this first question, can D and F be carried out by the same person? Well, the first thing to spot, I think, is that F is a critical activity. So we know for certain that F starts at 7 and ends at 10. So the question really is it possible to schedule activity D, given it's got some float here? We might be able to play around with the scheduling, but can we schedule it so it doesn't overlap with activity F? Now, okay, so if we started D at 4, it has a duration of 7, so it would take from 4 to 11, and actually then it would completely overlap with activity F, so that would be no good. Even if we delay it though, even if we delay it to the latest that D could possibly start, which must be 6, in order for it to be finished by 13, it's still going to overlap completely with F. So definitely not is the answer to the first question. What about I and H? Now then, I is here. Okay, so it's got a float of 2, and H is here. H is a critical activity, so if we focus on H again, we know that H must happen from 10 until 12. The question is, can we schedule I so that it doesn't overlap? And in fact, the answer is yes. So even though we could start I at 11, which would make it overlap, we could delay it until 12 or even as late as 13, and we can still make sure that it is completed by the latest finishing time of 16. So yes, I and H can be carried out by the same person. as for the effect of halving the duration of k, well, basically, because k is not a critical activity, if we can do k quicker, it's not actually going to help us that much. Um, it's only so basically halving the duration of the time for k will have no effect on the duration of the task because k is not critical. We'll still have this critical path that we have to get through, and we can't do that at less than 21, no matter how quickly we do k. However, if we double the duration of k, well, then that could potentially cause a problem. In fact, because that's going to increase it to longer than the total float it has, then it actually must affect the duration. So yes, doubling the length of k will actually mean that k will become a critical activity. So, if we started it at a time of 14, it would be taking 10 seconds now, or 10 units of time, and so it would last until 24. So the earliest we could finish by doubling k would be 24 rather than 21. So it's possible to take the information from our activity network and produce a chart like this, which is showing the scheduling. Now, to start with, we've set this up so that all of these activities, if you look at it carefully, they've been scheduled to start at their earliest start time. So in other words, we've not taken float into account yet. But just supposing that we do this, so suppose there's a starting point in our production process, we say, right, well, I just want everything to start as early as it possibly can. What effect is that going to have on the resourcing? So if you look carefully at that, pause the video if you need to, can you see what the maximum number of workers that we're going to be needing at any one time is? And hopefully what you see is that here, so between the times of 4 and 6, we have 4 things happening at once. So we would need 4 workers at the same time there. And actually also between 7 and 8, very briefly there, you'd need 4 workers as well. So the question that flows naturally from there is, by utilizing the float that we have on these activities, might it be possible to reschedule them so that fewer workers are going to be required at any one time? So by adding a bit of extra length with these dotted lines after these activities, that represents the float, so that the width of this dotted section is equal to the float, the total float for that activity, and that is showing that yes, for example here activity E can start as early as 4. If we delay it, we could delay the start to 6. It then has a duration of 4 and could finish as late as 10. So in other words, we can move that activity anywhere between the start and end of that space that it takes up, including its float. Now, in terms of the question we pose, unfortunately, in this situation, if we think about it, we can make things a little bit better. We can make the time for which we will need 4 people, we can reduce that time, but we can't avoid needing 4 people at all, because here between 7 and 8, even if I delay D by 2 seconds, or 2 units of time, which is what I can do here, it's still going to be present at this stage. Likewise with E. E is always going to be being carried out at this time between 7 and 8. But there's another question that we can ask, which is what changes need to be made so that the same machine can be used for activities B, D, I and L. So if those 4 activities need a particular machine, especially for those activities, that machine can only be used for one thing at a time. At the minute, if we look at those activities, so for example here B and D are overlapping, I is not overlapping with anything and L is not overlapping yet. However, if I do start to try to move D, that's then going to overlap with I, so I'm going to have to think carefully about this. It's not going to be just moving one thing, but try pausing your video now and see if you can see how we could maybe reschedule B, D, I and or L so that it is possible to do all 4 at once. One thing you need to be very careful about here is that if there are other activities that depend on one of those, that those activities might need to be delayed as well. And that actually gets into the idea of what we were talking about briefly in the previous video about independent float versus interfering float. So see what you make of that. Pause your video for a moment and try and resolve that. So firstly, it makes sense, doesn't it, for B to stay where it is. B is already starting early. It seems as if B wants to push D forward so that they're not overlapping. So the first thing we'll do, and really we don't have much choice here, if B and D aren't going to overlap, then we're going to have to move D so that it's doing that. So now B and D are not overlapping. Let's highlight B in blue as well. So I'm using the blue to show you where these things are going to be moved to. If we're not going to move it, I'm still going to highlight in blue where it's going to be. And of course now that means that D at the minute is overlapping with I, but I can move I along to here, maintaining its duration of 3. And then I need to make sure that doesn't overlap with L, so I can move L. Well, I could move L even further, but let's just move it as far as we need to, like that. Now that appears to be fine. That appears to have solved the problem. However, we do need to be careful. We're not quite done yet, because if you notice where K is dependent on activity I. So K can't start until I has finished. But it's still okay. I can move K along as well. There is enough float available in K to move that also. And so that will allow us to do what we are trying to do there. So hopefully you're getting a flavour for these techniques now and are seeing the usefulness in practical context of these things. You can imagine actually sitting down as a factory manager doing this and you know, really saving time and resources for your company by using the methods that we've been exploring in this topic. So that brings us to the end of this topic anyway. This is the end of video 1.5, resourcing and scheduling, and the end of the topic of critical path analysis.